Okay, so now we are doing this today's lead code contest. It is weekly 329. Okay, so weekly 329 date is 22 Jan 23, and these are the four question. Let's start with the first one or second one or third one. Let's start with the second one. Okay, sort the students by their K score, right? Okay, so you have been given a matrix containing m students, and each student have n exams. Okay, so m cross n, yeah, something like that. And then each row has each element is score of I, basically the marks student I scored in the exam J, right? And this are distinct integers only. Okay, you're also given integer K, sort the students by their scores. Okay, so distinct integer is important. Why? You'll see after a while. We are also given an integer K. Okay, so this integer K is basically sort the students of the kth column, which means kth basically K equal to 2. Yeah, basically you can say see exam number 2, or you can say the second column. And what you should do, you sort this in kind of order. So 11 9, in kind of decreasing order. So 9 11 and then 9 and then 3, decreasing order. But it's not like you just need to sort this column. You need to sort all the rows based on this, these values. So the 11 wala row will come at the first, the 9 wala row will come at the second, and the 3 wala row will come at the third, right? So this is the whole problem. 3 5, you have to sort about the first index, 3 and 5. So 5 wala row should come at first, 3 wala row should come at second. So this is all what you need to do. So pretty simple, straightforward problem. First, what you'll do, you'll just analyze your this column, right? You'll analyze this kth column, and then you will see which is the maximum. This should be my first one, which should be my second one, which should be my third one. How you'll gonna see that? Okay, so there are multiple things. So 5, you can say that 5 is actually a first row, in index wise first row. And this should come at the zeroth row. Or you can say 5 wala is a second row, and after placing it should come at first. Okay, so let me just do it. Yeah, this is implementation kind of problem. And straightforward logic, I just told you, analyze this column, see the values, and put the maximum on the first one, and so on, like, yeah, in decreasing order. And you have to make changes to the original matrix, right? But it's not like that. Like, let me show you. 0 equal to I less than n, these are the all number of rows in my case. And then I'm using x for storing the value of something like score of this person, like score of I at the column K. But we just don't need that. We need one thing also, which we need this row number, right? You'll see it after. Obviously you can see it, because why we need row number? We need 5, and we need the row number of 5, so that I can place this complete row at the place of zeroth row or first row, right? So which row I need to place? So that is the keep tracking of I is equal to that row. So that's why I created a vector of integers named something like x, and that's all about it. And then you need to sort x dot begin dot end, but in reverse order. You can write a custom comparator, but I think greater would work, right? And that's about it. And after having this, you need to just create another uh, final matrix which you need to return, right? Call it final matrix f. And then for not auto I into I equal to 0, I less than n, I plus plus, f of I is equal to something like s of which number? The number which this x is giving you. Okay, so x of I comma 1. What does this mean? This let's say I'm on the ith row. I need ith greatest row. So how I will get that? I will get that from this x vector storing the uh, greatest rows in terms of in on the ordering of basically kth column. So yeah, actually you need the ith greatest row based on the comparison of k kth column. Return your f value. Should work fine. Let's see compilation errors for sure in 10. The k is also zero indexing, so you need to not worry for that. I think I'm doing some mess up over here. And I to k, x of I comma 1, right? X of I comma 0 is value I comma 1. Hmm. Okay, you need to say like, yeah, it's size n, obviously. Now let's try sum this up. Accepted. Okay, let's move to problem number C. Applies bitwise operation to make string equal. You have been given two strings. Okay, and there is an operation. You can choose two indexes I and j in string s, and you can do replace si with si or s of j. You can do or of them. So basically these are 0 1, nothing else. 0 and 1, 0 and 1, or is obviously 1. Okay, and their XOR is obviously 1. But yeah, so any two number you will pick, any two index you will pick, they will have four combinations: 0 0 0 1 1 0 1 1, and then there will be output for that, right? And then you have to basically do or and write in the place of s of I, do XOR right in the place of sj, and then you need to tell, after doing any number of operations on this string s, can you get a target at any point. So the only thing which is important over here is, you can say it's a pattern based question, or pattern finding question. I'm saying like, look out at the number of ones, look out for the number of ones. That's what I'm saying. Hmm. How many ones does this string have? Let's say this have, okay, two number of ones. Okay, 1 is equal to 2, 0 is equal to 2. You don't need to see the exact ordering, you just need the number of zeros and ones. In your target, what do you have? Two ones, and zeros are also 2. So what I'm saying, if you are having, right, just check number of ones. Is it greater than 0? Yes. Two ones are there. So there must be two ones over here. If let's say 0 0 0 0, if let's say no one is there, you cannot have, you cannot form like this, because when you choose 2 0 0, when you choose 0 0, the or is equal to 0. XOR is also 0. So when you choose two zeros, you cannot have 0 1. So in case of when you have all zeros, you cannot generate this one in any case. So there must be 1 1. If there is 1 1, okay, then you can generate any number of ones that you want. 0 1 will give you two numbers basically. You don't need to see or XOR, you just need to see which two numbers it will give, because you can order them in any way. Okay, it's not like I is less than j, j can be less than I. So the numbers which is it is giving is, it is also giving 0 1. And if you have 1 comma 0, it is also giving 0 1. If you have 1 comma 1, it is also giving 0 1. So now what I'm saying, if it has some ones, okay, then it must have any one, because wherever you are having one, and you are you cannot demolish this one into 0. That is the thing. If you are on 1 1, you cannot say I can make 0 0. No, because let's say if there are only one, right? If there is any one, and let's say there are two ones, then you can do something. You can, let's say there are all ones, right? You can do something to make it all zeros, but 1 1 will still remain. Like, let's see these three ones, and then you do this operation 1 1, you'll make this 0 remain this as 1, and then you do operation between these two, it remains as 0, and make this 1. And then when you do operation between these two ones, you will make this as 0 and make this as 1. Now you don't have any other one. You cannot do again operation like 1 1 operation, but you can do 1 0 operation when you have 1 0. In this case, you cannot demolish this one. So the only logic of this problem, if s has 1 1, the answer is gonna be true. If we must have 1 1, not 1, but basically 1 greater than like has some ones, then answer is true. If we must, we also have some ones. Like in this case, s had many ones. S had many ones. T had only one. Okay, so T must have one. Okay, so if S has some ones, okay, if there is any one only, then T must also have someone. It can be zero. No, it cannot be zero. It can be one only or anything. Like it must have at least one. Must. So this is the logic of this problem for all the zeros and one kind of thing. Now, there is only one case, like when all zeros are there, where there is no one. You cannot generate any one in this. Okay, not even single one you cannot generate in this, right? So if S all zero, this is a special case, then T should be all zeros. So there is only one logic for this one. If S1 is equal to if S is equal to T, then it's fine. If not, then check number of ones. They both have any return. If S is equal to T, return 1. So one of the case of that gets covered over here. Which one? If they both are all 0, like if as has all 0 and T is all 0, this is covered now. You just need to see if S has some ones. If I is equal to 1, for I in T, uh, I O2 equal to plus plus, return O1 and O2. Any one of them cannot be 0. I just submitted it without seeing. Return 1. Why? There is problem in this. What's the issue? Oh, T is not defined. T is target. Ampersand actually works in bool variables. What is happening? O is equal to 0 and this is equal to 0. If I is equal to 1, O1 plus plus. See out. Let's see out what is the number of O1 and O2. I can see both have some ones, so the answer for this should be fine. I did not discuss any other case because in any other case you can just see pattern finding, like will get submitted, will get true. Okay, why is this happening? I is equal to 1. Auto I in this. Oh, sorry. It's 1 and it's also 1. Basically characters. These are characters. Accepted. Move to problem number D. And minimum cost to split array. It is also simple one. Okay. But we'll cover this in next video. So we should do A first. Yeah. So A is pretty straightforward. Alternate digit sum. You need to see the number and you need to do some of the digits in alternate fashion, like first digit plus, second minus, third plus. So what I did, I simply did not did anything except what he just said. I just calculated this vector of this 5 to 1, and then I moved around this vector, first number positive, second negative, third. So basically if index is even, then positive, otherwise negative. So this is vector. You can just standard algorithm to make a digit integer to digit vector. After having this digit vector, reverse this, because this will come out as in my case it comes out as reverse vector. Like for 5 and 2 the vector is 1 2 5, so I reverse it to into 5 to 1, and then index equal to even, I is equal to index equal to odd, then plus minus v, otherwise add like positive of this current element, and then you just need to see return s, which is sum. Okay, so that's about it. It's perfectly fine. It's nothing, but we'll do fourth question. But yeah, okay, after some time. Okay, guys.